Hello students, this is the continuation of our discussion on motion, and obviously in motion we have discussed distance, displacement, velocity, speed, and then distance time graph and velocity time graph. So this time we are going to solve few MCQs based on distance time graph and speed time graph. So the first question is here, and here you can see that the diagram show the distance time graph for an object moving in a straight line. What is the average speed between x and y? In the theory, I have discussed this point that obviously the graph is not showing the actual path of the body, but this is the you can say line which will describe the motion of the body. As far as the average speed is concerned, you have a simple formula, and for this you have average speed. Average speed is nothing but total distance divided by total time. So what is the total distance and what is the total time? So between these 2 points, the time is 20 and the distance is this distance, and from 6 to 12. So simply you can say 6 divided by 20 will give you the answer. And when you will calculate, so simply you will get 0.30. So you can say that the answer is nothing but B. I hope it's clear. It's very simple formula. Average speed, you can write if you want average in this way. Average speed is equal to total distance divided by total time. So this is very simple, but remember this point that they are not asking average speed from 0 onward, but they are just mentioning here that the average speed between x and y is required. So be careful. X and y. So x and y is only this distance, or simply you can say this distance, and the time is obviously 20. So you will calculate like this. Second question is here. The diagrams show distance time graphs for 4 objects. So you have here 4 diagrams for 4 objects, and obviously the distance time graph we are talking about. Which graph represents an object moving with an increasing speed? Increasing speed. So what we have to recall, for details of course you can go to my lecture where we have discussed the distance time graphs in detail. But one point which is very important to remember is that the gradient or the rate of change of distance is nothing but the velocity. So what they are saying, increasing speed, so it means that the rate of change must be increasing, and rate of change is nothing but the gradient. So what you can say and what you can see, that obviously here you do not have any gradient, so this is not the answer. Here the gradient is constant, yani velocity is constant or speed is constant, so this is not the answer because we need increasing speed thing. Over here the gradient is decreasing or the slope is decreasing. So remember this point that in this case the velocity is decreasing or speed is decreasing, so this will not be the answer. So obviously when 3 are not answers, fourth will be answer. This is one logic, but actually the point is here you have the gradient in this case and the gradient in this case is increasing with time. So as you know that the gradient is nothing but the speed, so you can say that here we are dealing with the body which is moving with increasing speed. So simply the answer is nothing but D. I hope the point is clear. If you are new on this channel, subscribe this channel, and obviously if you like this discussion, uh, uh, like this discussion, and obviously share with other students as well. So this is the second question. Then third, I have actually selected few of your distance time graph and speed time graph curves. The third one is here. Which graph represents an object that is moving at constant speed? Constant speed. So here you have the constant distance. Constant distance means obviously the gradient is zero. So it's not constant speed, it's constant distance. So this is not the answer. Then B, here you can say and see that the distance is increasing with time. The distance is increasing with time. So here you have different slopes. The slope is increasing. So this is not our answer because we need constant speed. In this case, what is happening? The gradient is decreasing, whether it's negative or positive, but it's decreasing. So again, you can say that the velocity is not constant. But over here, as the gradient is constant, so simply you can say that answer is nothing but D. And you can see that in all these questions, no calculations are required, only the concept which you will learn, you have to apply, and that's it. So if you know the concept, it will not take much time. So this is your question number 3. Then you have question number 4. Four objects, this time 4 objects are moving along a straight line. The distance of an object from a fixed point on the line is plotted against the time for each object. Which object is decelerating? So you know that when you are talking about the deceleration, it means that the velocity is decreasing. Velocity is decreasing. Velocity is not increasing. So in this case, you can say and see that the gradient is constant. So velocity is constant. So this is not our required answer. Here you can say and see that the gradient is increasing with time, yani velocity is increasing with time. So when the velocity increases, acceleration, yani the body will accelerate. So this is not our answer. In C, when you will try these tangents, you will see that the tangents are constantly decreasing, yani velocity is decreasing. And velocity decreasing means the rate of change of velocity is negative, and therefore the body is decelerating. So simply you can say that this is our answer. Answer is nothing but C. Obviously, in case of D, you have again the constant gradient. So you can say that the velocity is constant, but it's not decelerating. Decelerating means change in velocity in negative with a negative rate. So the point is that here the initial velocity is greater, and suppose this is your final velocity, or you can take that here you have one velocity, this velocity you can take as final velocity. So you can say that for each step the velocity, which is the initial velocity, is greater and the final velocity is lesser. So when you will go a is equal to v minus u divided by t, so this will give you a negative value. As I said that v is less than u, so obviously the value over here will be any value of acceleration will be negative. So the body is decelerating. This is the situation. I hope is the concept is clear. Then we have question number 5. In question number 5, again, what you can see, the distance time graph for a motorway journey is shown. Yani the car or the body is moving, and what is happening here? Obviously, they have plotted time along x-axis and they have plotted distance along the y-axis, which is actually the way to represent the distance time graph, because distance is the dependent quantity, and time is the independent quantity. So what is the average speed of the for the journey? So here they are talking about average speed for the journey. So if you can recall, the first question was only between 2 points, average velocity or speed between 2 points only during the journey. But in this case, they are asking the average speed for the journey, yani from this point to this point you have to calculate the average velocity. But again, as you know that average speed or velocity is simply nothing but total distance divided by total time. So what is the total distance? So simply you will say that here you have the maximum distance, whatever the path they are following or whatever the situation of the velocity and state of the body you can say, but ultimately the distance covered is 100 in how much time? 120. So when you will divide this 100 by 120, you will get something like this, 10 divided by 12. But here you have to remember one more thing, and that point is about the unit. Here you can say and see that the unit is minute, but in all answers you can see that we are dealing with hours. Any answers are in hours. So what we have to do, we have to consider that is this 12 is not the hours thing, but it is minute. So what you can say, you have to divide it by 60 to get hours. So something like this you will get 600 divided by 12, and ultimately you will get 50. So this will be your answer. So here not only you have to consider what is the total distance and what is the total time, but you have to think about the unit of the time. As I said that in this case the unit is minute, but all answers are in hours. So what you have to do, you have to convert your minutes into hours. So 120 you can do it here at this stage whatever, but the answer will be 50 kilometers per hour. So this is how you will get the right answer. So the answer is A. So the fifth question in this case, the answer is A. Okay. Then we have this question is based on the speed time graph. As you can see, the diagram shows the speed time graph of an object. In which section does the object have the largest acceleration? So again, you have to recall that if you have the speed time graph, how you will get the acceleration thing. And we know that the gradient or slope of the graph, gradient slope of ST graph is acceleration. So what actually we have to check for this answer, where we have the greatest slope or largest value of the acceleration. So simply you can say that the slope in this case is B, which is the greatest. So simply you can say the answer will be B as well. यानी हमें ये देखना है कि आपके पास स्लोप सबसे ज़्यादा किसका है. So this part or this portion has the maximum slope. So the answer simply for the largest acceleration over here, यानी this portion or section is giving us the value of the largest acceleration. So actually you have to recall that what are the values or from where we can get the values of the acceleration in case of the speed time graph. Obviously again here you have speed dependent quantity and time as the independent quantity. So you have taken time along x-axis and the speed along y-axis. So this is how you are getting all these information. So this is your question number 6. Then you will go to question number 7. The diagram shows how the speed of a falling object changes with time. So falling objects here you are considering. So what is the situation here? Again, the point is same. Speed time graph. So what is happening? The slope is decreasing. So it means that what is happening in this case? So simply you can say that the gradient or slope is decreasing. Slope is decreasing. The diagram shows how the speed of a falling object changes with time. So what is happening over here? The slope of this curve is decreasing. So what is happening? This is important. Speed is decreasing. Speed is increasing with decreasing rate. So speed is increasing, be careful. So when the speed is increasing, so you can say that the value is Yani the body is accelerating. Be careful. Accelerating. And ultimately, what is the situation over here? The E becomes constant. So the body is not at rest, but the body is accelerating and the speed is constant. So be careful of this part. Which row describes the motion of an object between x and y and between y and z? So between x and y, as I said that over here, still the body, the speed of the body is increasing. So you can say that the body is still accelerating. But obviously between y and z, what will happen? The speed becomes constant. Be careful that this part, in case of speed time graph, this part is not showing you that the body is at rest, but this part is showing you that the body is moving with constant speed. So this is very important to remember the difference between the distance time graph and speed time graph. If you will have the situation of the speed time distance time graph, suppose this way, then you can say that d, if we have d here and time obviously along x-axis, then this part is showing you that there is no change in the displacement, yani body is at rest. But in this case, the body is not at rest, the body is still moving. Only one thing is that the speed is constant. So be careful that whether you are dealing with the speed time graph or you are dealing with the distance time graph, as in the previous first I think 4 or 5 questions we have discussed distance time graph thing. Then obviously the rest are not correct. So the speed time graph again represents the journey. So what is happening? You are starting from this point, yani the distance is not increasing from this point, but the speed you are you can say you are starting the measurement of the speed from this point, and obviously in different sections you have different situations. Which how does the graph show that the distance traveled in section x of the journey is greater than the distance traveled in section y? So here what actually we have to consider and recall, that in case of speed time graph, when you have a speed time graph, the area under the curve will give you the distance cover. So what is the first option, or option A? The area under section xy of the graph is greater than the area under section y. So this is actually what they were asking. So simply you can say that answer is nothing but A. Simple thing is that here we are not talking about the gradient, be careful. Here we are interested to know that what is the area under the curve. So under the section X, the area is greater as compared to the area of the under section Y. So simply you can say that this part shows. How does the graph show? So this is actually the right answer, that the area under section X of the graph is greater than the area under section Y. So it's very simple. The rest obviously are not correct. Then here the diagram shows speed time graphs for 4 different bodies moving for 6 seconds. Any time is same for all graphs. Which body travel the least distance? Again, here you have to consider one very simple thing, that the area under the curve, obviously here we are talking about velocity time graph, will be the distance covered. So what you have to do, you have to calculate the area under the curve. In this case, you have a triangle, area under the curve is a triangle. So what will be the calculation? For this area, half into 6, yani time, into 8, yani speed. You know that the area of the triangle is given by half base into height. This is the area of triangle. So obviously if you are considering OPQ, so you can write here OPQ triangle, and obviously this will be the calculation. So what you are getting here, 2 4s are 8, so 4 6 are 24 meter. And obviously you have to calculate other you can say options as well. So like suppose here, as we are talking about the distance, so this for distance we have to calculate the total area covered. So here what you have, half. Remember one thing, you need to find out least distance. So half in this case, again you have two triangles, triangle 1 and triangle 2. So for triangle 1 you have a situation like 2 multiplied by 4 into 8, and obviously when you will go for the second triangle you will say and see that here we have half, base is 6 minus 4, which is 2, and height is nothing but 4. So what you are getting here, 2 2s are 4, 2 8s are 16, and over here you will cancel out. So the value of the distance in this case is 20 meter. Obviously in this case the whole rectangle is your area of consideration. And what will be the situation in this case? So 6 into 8, and you will have over here 6 8s are 48. So this is the value over here. And in this case obviously you can divide this part into 2. Again 8, and over here you have 4 plus this is your height, and here you have the you can say time, or the other side of the rectangle. And in this case you have two rectangles, 1 and 2. The first rectangle is giving you 4 and 8, yani 32, and over here you have 2 and 4. So 2 4s are 8. So here you are getting 40. So simply you can say that the answer will be 4. Sorry, B. Yani the least distance is nothing but 20. So this will be your answer. Obviously here you learn another thing, that out of 8 9 questions we have only one question where we need to calculate something. Otherwise if you have concept of gradient and area under the curve and all these, very quickly you can give the answer. So out of your like 40 questions, maximum 10 questions you will have where you need to calculate something. Otherwise most of the questions are conceptual based, you can say. Then in question 10, the graph shows how the speed of an object varies with time. What is happening in this case? Obviously speed time graph you have. Which row describes the motion of an object at times P and Q? So what is happening at P? So simply you can say that as the value of the speed is constant, yani there is no slope, so there is no acceleration, but the velocity or speed is constant throughout. So simple one point which you have to remember, that if you can reject any options, like here you can reject first two options because the P is not showing you the body at rest but moving with constant speed. Now you have 50-50 chance to get the correct answer. But in this case what is happening, when you will go to the section Q, what you will say, that there is the positive gradient, yani the body is accelerating, it's not decelerating. So it means that the option D you will reject, and in this way you will go to the correct answer, and this is nothing but C. So this is very important to remember, that this is another way to get the correct answer, that if you will reject few answers, obviously you can approach or you can target the correct answer more easily. Question number 11. The motion of an object is represented by the speed time graph. Again, you have a speed time graph over here. Which quantity is equal to the area under the graph? Area under the graph. So we have already actually discussed in theory, and I think is a very straightforward question, that this is nothing but the distance traveled. Area under the graph is nothing but distance traveled. So you can see that you spend some time in the calculation in question 9, but the next two questions very quickly you can solve, because there is no calculation at all. So this is how you will actually get questions in your final paper as well. Then question number 12. The graph shows how the speed of an object varies with time. Again, the speed time graph actually we have. At which level time is the acceleration greatest? So again, the simple thing is that when you will talk about the acceleration, you know that the speed time graph, if you have, then the gradient of the speed time graph is giving you or will give you the acceleration. So where you have the greatest, you can say, slope. So this is the area where you have the greatest slope, and you can say and see that this area, any section C or part C of the graph, is not giving you the maximum acceleration or greatest acceleration. So simple answer you have is section A. Be careful that you are going for the greatest slope. So sections A you have the greatest slope, the rest are not. Then 13, the graph shows how the speed of an object changes with time. How far does the object travel in 10 seconds? So again, here they are talking about the how far, yani they are asking for the distance covered, and you know that the area under the curve, yani area under the triangle, will give you the answer. So how you are getting? Half into breadth into height. This is the area of the triangle. So simply half into 10, which is somewhere here. This is time actually. And as far as the h is concerned, obviously we are not talking about the actual height, but the height of the triangle. So this is nothing but 8. This is giving you the value over here, which is 8. So what you are getting? You are getting 40 meter. So the answer is very simple, and this is nothing but C. So in most of the cases, actually only two things you have to remember: what is the slope of the speed time graph and what is the area under the curve. If you can find out these two things, you can find out the acceleration and distance covered respectively. And here you have question number 14. In question number 14, you can say and see that we have the combination of few graphs. So distance time graph, but otherwise we have speed time graph. What the question is, in this case, a cyclist records his speed and the distance traveled during a journey. So distance and obviously the speed they are measuring, and they are plotting their respective graphs. He then plots the data against time for different sections of his journey. Which graph shows a section when he is moving with constant speed? Constant speed. So be careful. Constant speed. So when you will go again for that concept, here first of all you will see that when you are talking about the graph 1, here you have constant distance, not constant speed. Constant distance means you have a body at rest at a particular distance from you. So this is not the case of the constant speed, so you can simply cancel this option. Then you have the option B, which is a speed time graph. In this case, you know that here you have the constant gradient, any constant slope, and as we have discussed that in speed time graph, the gradient is acceleration. So this is not the constant speed. The speed is constantly increasing in this case. So the acceleration is constant in this case. So this is not our answer. And in this case, you can say and see that the gradient of this graph and the distance time graph is nothing but the speed. So V is equal to S over T or del S over del T. So this is something which is required. Yani constant speed means in case of distance time graph, the constant gradient or constant slope. So the answer is nothing but C. So obviously the D is not correct. So in this case, speed is decreasing. In this case, the speed is increasing, and obviously for so you can your answer A, yeah, option A, not answer. Option A, here you have the constant speed, constant distance, but what constant speed, distance means that the body is not moving, the body is at rest. So obviously we will reject this option as well. Then question number 15, the speed time graph represents a short journey. Here you can see that the speed is constantly increasing. Which distance time graph represents the same journey? And over here they have given you the speed time graph, and you need to draw, you can say, the distance time graph. Obviously you are not going to draw here, but if you will have the theory paper, that this will be the question, but here they have already given you these graphs, so you have to just recall your memories and you will get the answer. So what is the situation here? Which distance time graph represent the same journey? So what is the situation here? Acceleration is constant and the velocity is constantly increasing. So in this case, here you can say again or recall, for A, the gradient is decreasing with time. And what was the gradient here? The speed. So in this case, the speed is decreasing. So this is not the case. Speed is increasing in this case. So this is not the correct answer. For B, you can say and see that the slope or the gradient is increasing, and you know that the slope in case of distance time graph gives us the speed. So here you have the constant increase in speed. So here you have the constant increase in speed. So the answer is nothing but B. And obviously, as we have discussed before as well, that in case of C, we have wrong answer, because here we are not, you can say, have a body which is moving. Here you have the body is at rest, because the distance is not changing from the observer for different intervals of time. And again here you have the situation where the speed is constant. Here the speed is constant because the slope of distance time graph is nothing but speed, which is constant in this case. So we need a situation where the you can say the velocity or speed increasing. So our option is nothing but B. I hope these questions are giving you a more clear picture of speed time graph and distance time graphs. So a few of these questions I have solved in this section, and if you like this, so share this with other students as well. Subscribe my channel if you are new in for this channel, and obviously when you will subscribe, so as I am uploading constantly these lectures, so you can enjoy and you can get the benefit out of these your lectures and your the solution of the problem as well. So take care. Allah Hafiz.